Advanced Water Treatment Techniques and Process Management. This time, we will find out about various advanced water treatment process and its management techniques. This lecture will allow you to cultivate your operational abilities by understanding the concepts, principles, and examples of advanced water treatment processes. The topics covered in order will be an overview of advanced water treatment, ozone, advanced oxidation, activated carbon, UV and AOP, and membrane filtration. Overview of advanced water treatment. Advanced water treatment is a technology that treats various harmful substances which are not removed by the filtration and chlorine treatment of the general water treatment process. And typical examples include ozone, granular activated carbon, ultraviolet light, and membrane separation technology. If we look at the substance to be removed according to the process of the advanced water treatment, the general water treatment process is a technology that removes suspended matter and microbes. On the other hand, the advanced water treatment removes small-sized substances that are dissolved in the water, such as taste, odor substance, pesticides, disinfection byproducts, and trace organic matter. Ozone removes substance by oxidation dissolution with reinforced oxidation power, and activated carbon removes it by adsorption. Ozone and UV process can be converted to advanced oxidation processes by further increasing oxidative synthesis with the combined use of hydrogen peroxide. Membrane filtration removes certain substance through size exclusion, but it is classified as an alternative filtration process because the microfiltration and ultrafiltration remove suspended matter and microbes like the general water treatment. However, nanofiltration and reverse osmosis methods have the function for the advanced water treatment since they remove dissolved substance including ionic substance in water. Each unit of advanced water treatment process can be used in various combinations depending on the quality of raw water. Most of the advanced water treatment process in Korea is composed of combinations of ozone and granular activated carbon and were introduced to remove the taste, odor substance, and trace organic matter from raw water. Ozone, advanced oxidation. Let's find out more about ozone and advanced oxidation process. Initially, ozone was used in the purification plants for disinfection purpose, but after the discovery of its various effects, aside from disinfection, on water treatment improvements using its strong oxidation power, it is operated as the advanced water treatment process and is being operated in over 2,000 purification plants worldwide. The raw material gas of ozone generator can be either air or oxygen. When using air as the raw material, ozone can generate 3 to 4 weight%, and with oxygen, 10 to 15 weight%. Recently, the ejector method, which uses oxygen as a raw material and injects ozone directly into the main pipe of dissolution, is being widely adopted. Since the ejector method has a high ozone dissolution rate, advanced water treatment efficiency can be obtained, even with a low ozone injection rate. The current silent discharge method is widely used as a method for producing a large amount of ozone. As shown in the figure, the silent discharge method uses an electric discharge phenomenon generated by applying tens of kilovolt of alternating current voltage to the electrode that has placed the dielectric in between the electrode, and it creates a very unstable ozone from the air or oxygen in the electric discharge space. Ozone is a very unstable substance and has strong oxidizing power, so all facilities handling ozone must use corrosion-resistant materials. And if leaked, it is harmful to the human body, so it must be removed through an exhaust ozone destroyer. Pre-ozonation refers to ozonation at the water intake stage, and intermediate ozonation refers to ozonation after the settling tank, followed by post-ozonation treatment after the sand filter. Post-ozone is effective for treating taste and odor substances. In general, it is common to connect the post-ozone and granular activated carbon process to operate as bioactivated carbon. By operating with bioactivated carbon, the service life of activated carbon can be increased. In Korea, when raw water quality is very poor, pre-ozonation is additionally introduced and operated. Pre-ozonation can substitute pre-chlorine and achieve various water quality improvement effects, such as reduction of disinfection byproducts, such as trimethanes, removal of algae, and removal of iron and manganese. Ozone has been proven to be the most effective disinfectant in almost all investigations and studies. The sterilization principle of chlorine damages the enzyme by permeation of the cell wall. But ozone shows a strong sterilization effect by cell lysis of the bacterial cell membrane. Ozone has 5 to 25 times higher disinfection effect against viruses and bacteria than chlorine. Advanced oxidation process is a method of decomposing difficult to decompose organic matter by accelerating the generation of OH radicals with strong oxidizing power by using 2 or more oxidation processes in combination. It is a technology that promotes decomposition of organic matter by increasing the generation of OH radicals by adding hydrogen peroxide before the ozone process. In the case of taste and odor substances, the removal efficiency can be increased by about 20 to 30% compared to the ozone-only process. There are 2 methods to control the ozone injection rate in the actual water purification plant: the ozone injection amount control method and the residual ozone control method. Ozone injection amount control is a method of adjusting the ozone injection rate in proportion to the concentration of taste and odor substances in raw water when taste and odor substances are generated. In case of AOP operation, the ideal hydrogen peroxide injection amount is 1/3 of the ozone injection. Residual ozone control is a method of maintaining a constant level of residual ozone at the outlet of the ozone contact tank and injecting ozone as much as the ozone consumption of the raw water. This is a useful method when you want to maintain the level of disinfection function in the ozone contact tank in usual time when no taste or odor substances are generated. Activated carbon. Activated carbon is a technology that removes adsorbable harmful substances using countless pores inside the activated carbon, made by carbonizing coconut shells, coal, and wood at high temperatures. Carbon is a very eco-friendly water treatment agent because it does not produce any byproducts in contact with water. The raw materials of activated carbon used for water treatment include coconut shells, wood, and coal, and in Korea, coal-based materials, which are effective in removing taste and odor substances, are mainly used. Depending on its form, it is divided into powder activated carbon, granular activated carbon, and biological activated carbon. Bioactivated carbon is a technology that enables long-term use by regenerating granular activated carbon or extending its period of use. And it also removes the organic matter in the water through adsorption and biological decomposition by attaching microbes on the surface of activated carbon. In general, GAC is converted to back in 4 to 6 months, that it is common to operate most of the bioactivated carbon process at home and foreign. There are 3 main types of water treatment application of activated carbon. Powder activated carbon treatment is a temporary method used when the frequency of occurrence of taste and odor substances in raw water is low. On the other hand, the granular activated carbon process is a method of continuously using granular activated carbon by filling it like sand on a filter paper. The granular activated carbon process is also divided into 2 types. The first is the filter adsorber process, which is for filter paper. This is a process that performs adsorption and filtration at the same time by improving the existing filter paper at the rear end of the settling tank and filling the upper portion with sand under the granular activated carbon. The second is the post-adsorber process, which makes and uses a separate granular activated carbon paper after the filter paper. Most of the advanced treatment plants in Korea are adopting this method. when granular activated carbon is used for a certain period of time. The treatment efficiency decreases, and the activated carbon replacement or regeneration process is required. As a regeneration method, heat regeneration method is mainly used. Activated carbon is economical if regenerated after long-term use, but high-temperature heat must be applied to increase the regenerated quality. If a lot of heat is applied, the amount of ash in the activated carbon will increase, and the regeneration yield will decrease, which will likely increase the cost of purchasing new coal for the shortfall. Therefore, it is important to choose the regeneration schedule carefully. When operating activated carbon, backwash is the most important part. Activated carbon backwash cycle is preferably within 5 to 10 days depending on the water temperature. Especially in summer, microbes can proliferate excessively and leak on the surface of the activated carbon. So, it is preferable to backwash within 5 days. During so, sufficient expansion rate must be secured when rinsing with water. Air wash is required when the layer of activated carbon depth is deep. However, since the activated carbon is weaker than sand, excessive air washing may result in powder coal leakage. Therefore, it is necessary to minimize the air wash time to about 1 to 2 minutes. UV and AOP. In the old times, we disinfected dishcloths, cutting boards, and blankets by exposing them out in the sun when the weather is good. This is possible by using the disinfection effect of sunlight. UV is in a territory between visible light and X-rays among the sun's rays. Even though UV has a short wavelength and low penetrating power, it has strong energy, so it can promote chemical reactions, oxidize organic matter, and sterilize microbes. In particular, the wavelength of UVC, which is called a sterilization line, is effective for disinfection. Unlike chemical disinfection, such as chlorine and ozone, UV disinfection is a physical disinfection method that uses the characteristics of light and is an eco-friendly disinfection method that does not create byproducts harmful to the human body. Compared to ozone, it is economical, easy to operate, and has the advantage of being much more effective in disinfecting Cryptosporidium and Giardia. UV can also be used as an AOP process to remove difficult-to-decompose organic matter by using it in combination with ozone or hydrogen peroxide. Membrane filtration. The advantages of the membrane filtration process are: first, it is possible to secure stable water quality that is not affected by raw water and pretreatment operating conditions. Second, it is easy to operate automatically. And third, it requires a small site area. In the water treatment field, the material to be treated is different depending on the gap of the filtration membrane. And it is divided into microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration or ultrafiltration method is used to remove suspended material and pathogenic microbes in raw water. Nanofiltration method can remove even dissolved organic matter and ionic matter. And reverse osmosis method is mainly used in the field of seawater desalination. The membrane filtration process operation method is largely divided into a pressurization type and an immersion type. The pressurization type is a filtration method that mounts a separation membrane on a module and pumps raw water to the membrane module with a pump. The immersion type is a filtration method that uses a water level difference or a suction pump by putting a separation membrane in the water tank. The pressurization method is advantageous for enlargement and process automation and is widely used in water treatment. And the immersion method is capable of treating high concentration and high viscosity solutions and is mainly applied to wastewater treatment. The main parameters in the design of membrane filtration facility are the membrane filtration flow rate, pressure, water temperature, and recovery rate. Since they are closely related to each other, it is necessary to take them into account when designing, although it depends on the type of membrane module. In general, the recovery rate of membrane filtration facility is designed to be 90% or more. The recovery rate of the entire membrane filtration facility can be improved by remembrane filtering the physical washing water or returning the treated water from the wastewater treatment facility to the raw water side. Regarding membrane cleaning, there is physical cleaning and chemical cleaning. Falling substances, which lead to reduced flow rate through a membrane filter or increased differential pressure, can mostly be removed through physical cleaning. However, if it is blocked with material that cannot be removed through repeated cleanings, the material slowly accumulates inside the membrane. In this case, chemical cleaning, also called CIP, must be used to break down or dissolve adhered material with chemicals. The measures to be taken when various problems occur in the operation of the membrane filtration process are shown in the table. If interlude borrowing increases, perform physical washing or chemical washing, and if turbidity or particles increase, it is necessary to check through a membrane breakage test. Thank you for listening.